Hello and welcome to this tutorial series on Elixir GenServers. This video series is for anyone who is learning Elixir and has come across GenServers and wants to learn more or see how they're built out. So we're going to map this idea to milking cows on a farm. So by the end of the series, you'll hopefully have a basic grasp of GenServers, how they can be used to coordinate large numbers of tasks, all with just a few lines of Elixir code. So this is my sort of plan for the series. So in the first video now we're going to implement cow and CowServer modules. Then in the next video we'll add a cow supervisor to supervise our cow processes. Then we'll add a cow registry so we can register our cow processes, which will kind of feed into the fourth video where we add a farmer process where farmers can milk our cows. And we'll add a dynamic supervisor in the fifth video so we can add more farmer processes while our application is after application started and is running. So a few prerequisites. You'll need to have Elixir installed and ensure that you can run IEX. IEX is just Elixir's REPL. So this is where we're gonna run our application and send our processes messages and things. But the first thing we're going to do is create our Elixir project. I'm going to create that using mix. So I'll just do mix new farm, and then I'm going to go into my new farm project, and I'm going to open this project in a code editor, and we can start to implement the cow and the CowServer modules. Okay, so I've just opened the project in my code editor, and the first thing I want to do is go into the lib folder, and I want to add another folder within here called farm. So I'll just add that, and then within farm I want to add two files, one called cow.ex and another called CowServer.ex. So in our cow file, we'll have the cow module, and that's where we'll define what an individual cow can do, like eating or being milked. There's going to be no concurrency or no processes here, just the behavior of an individual cow. Then in the CowServer file, that's where we'll have our CowServer module. So that's where we'll manage the states of all the different cow processes, handle any incoming messages, etc. So I'll just get started now by adding the cow module. So I'll just do def module cow form.cow do, and then I want to add a series of functions here. So the first one I'm just going to add a new function. So this is what our server module is going to use to initialize our cow processes. So I'll do def new, and then I'm going to take one argument, which is name. It's going to be the name of the cow, and all I'm going to do is return a map with the name and the cow's milk level, which whenever we initialize is going to be 0. Then another function I want to add is an eat function. So whenever a cow eats, we're going to add 1 to the milk level. So I can update the milk level using this notation. I can just say milk level is going to be cow.milk level plus 1. And then I'm going to add a milk function as well. So this is going to set the cow's milk level back to 0. And I can use the same notation as before. I can just say milk level is now going to be 0. And then I'm going to add a fourth function, and this is just going to check if the cow is full. So I'm going to do def full. It takes cow as an argument, and I'm going to say cow.milk level is greater than or equal to the max milk level, which is just going to be compile time value. And I'm going to set that at the top of the module to be 5. Max milk level 5. So yeah, this is everything I want to implement for the cow module, and next we'll implement the CowServer module. And sorry, just before we move on to implementing the CowServer module, I noticed a small mistake here. This shouldn't be in parentheses. It should be just cow level +1 like this. So sorry about that. And now we'll move on to the implementing the CowServer module. Okay, so I'll start by writing def module farm.cowserver do, and then under the module definition here, I'm going to write use GenServer. So what the use keyword does is it injects code from the GenServer module into our CowServer module, so we don't have to worry about any of that client-server boilerplate. There's a great book called Elixir in Action, which goes through how a GenServer is built up from scratch. So if you want to learn more about that, I'd recommend that book. But this video series is strictly for using GenServers, so I'm gonna skip over that. Then the first function I'm gonna write in our CowServer module is the init function. So I'll do def init. It'll take one argument, which is going to be the name of our cow, and then I'm just going to return an OK tuple with our initial cow state. So I already wrote a function in the cow module for getting the new cow state, so I'm just going to call this function. So farm.cow.new, and then I'll pass it the name. So because the init function, I didn't explain this, but the init function is defined in the GenServer as a behavior. So I'm going to tag this function as @impl GenServer. So now that we've added the init function, we want to be able to handle a few calls and casts. A call is synchronous, so the caller will expect a reply and will crash if it doesn't. A cast is asynchronous, so it's more like a fire and forget. So I'll implement the eat and milk functionality as casts, and then the fill, I'm gonna want to be able to handle a fill call so we can return to the caller if the cow is full. So we'll start with handling a milk message through a cast. So I'll do def handle cast. The request is going to be milk, and then it also takes the state of this cow process, and then I can use that state and pass that to the milk function, which is defined in the cow module. So I'll just do farm.cow.milk, and then pass it the state. And then because this is a cast, I can just do a no reply. So of course no reply is expected with the new state. And this is also a behavior defined by GenServer, so I can just add the same tag to this function. And then I also want to be able to cast eat requests. So I'm just going to copy and paste this and do eat farm.cow.eat state. So this is going to return the new state after the cow is eaten. And then I also want to implement a handle call for checking if the cow is full. So I'll do def handle call, and the request is full. And then you can also see that there's a third argument here, and this is just the caller, so which process is making this request. And I've prefixed this with an underscore because I don't want to use this in this function just yet, so I'm going to leave it like that. And then I can just do this time I'm going to do reply instead of no reply. And just going to, this is a 3-element tuple. The second element is the body of or what's in the reply. So I'm just going to do farm.cow.fill. And then the third element of the tuple is the new state. Of course, our state doesn't change if we're checking if the cow is full, so I can just write state here so that nothing's changed. And then, of course, this behavior is also defined by GenServer, so I'm going to add the tag to the function. And sorry, I just noticed I made a mistake here. I wrote cow here instead of state, so I'll just change that quickly. And that's it. That's everything I want to implement for our CowServer module for the moment. Now we're going to run the application and start some processes and see how this is all working together. Okay, so we're back to our terminal now and we're going to run the project. So to do that, just do IEX-S mix, and the -s mix just includes all of our project files in the REPL. So if I do that, I should be able to start our cow processes. So I can do that by writing GenServer.start, and then this takes two arguments. The first is our server module name, so I'll do farm.CowServer, and then the initialization argument, which is going to be the name, so I'll just call this tutorial. So what this function returns is hopefully an OK tuple with our process ID of this tutorial cow process. So I'm going to pattern match on that so that we have the process ID and we can send it, we can do calls and casts on this process. So we'll do OK process ID equals GenServer.start CowServer with the name tutorial. Okay, so we got an OK tuple back with our process ID, and now we can do some calls and casts. So the first thing I want to do is make the cow eat. So I can do GenServer.cast, and this takes two arguments, the first of which is the process ID, and then the second is the request. So it's going to be eat. You can see the cow, it returns OK. So I assume what's happening behind the scenes is that one got added to the milk level, another one got added to the milk level. So I can check if the cow is full now. I can do GenServer.call instead of cast, passing it our process ID and our request, which is full. So it should be false because we set the max milk level to be 5. Yeah, so it is false. If I continue to do eat casts, and then I call the full function again, you see this returns true now because the cow is full. And then the last function we implemented that we haven't covered yet is the milk function. So I can do GenServer.cast process ID with the milk request. It should return OK, and then if I check if it's full now, it should be false again because its milk level got set back to 0. So there's a couple of other things I want to implement before the end of this video, so we'll go back to the code editor and do that. Okay, so I'm back in the code editor now, and I said I wanted to implement one last thing just before the end of this video, and that is that I want the cow to automatically start eating whenever it's after it's initialized. So I can do that by writing process.sendAfter, and then the destination, which is going to be this process itself. So I can just write self. This references the current process. What the request is, so it's going to be eat, and then how the time it takes, or how long after I want this message to send. So I'm going to do after 1 second. So 1 second after the cow process starts, it's going to eat. But this doesn't get handled in a handle cast. This is a different kind of message. So this has to be handled by a function called handleInfo, which is also a GenServer callback. So I can just write impl GenServer up here, and the message is going to be eat, and of course the state. So this is just our cow state. So I want to, because this is happening automatically, I'd like to just add a little log to see if this is working okay. So I can do, I'll start by updating the state. So I'll say new state equals farm.cow.eat, and then I'll do io.puts, so we can see this on the console. So I'm gonna just do cow.name, so new state dot name has eaten, and then I'll say the milk level, and then I'll see what the milk level is as well. New state dot milk level. And then I want the cow to eat again, but only if it isn't full. So I can say unless farm dot cow dot fill, new state. And then I'm gonna do this again. So it's gonna send itself another eat message, and continue to eat until it's full. And then the reply for, or what we need to return from the handle info is no reply, and the new state. All right, so now whenever we start a cow process using GenServer.start, after a second, it'll handle this eat message, and then we should see this on the console. So the cow name has eaten, and then its new milk level, and then we'll see that every second until the cow is full. So I'm just going to do recompile, so we get all our new code, and then I'm going to do GenServer.start, or yeah, GenServer.start, just with the same command we used to start our cow process the first time. Only this time we should see the eat messages, or the eat log coming through to the console. So it should get to 5 and then stop. Okay, nice, all good. And then also, after the cow gets milked, I'd like to send it another eat message. So I can just copy this line and paste it in here. That should do it. So if I recompile again, start the process again, once it gets to 5, I'm gonna do the milk call. So I'll do GenServer, or sorry, the milk cast PID milk. You see the cow starts to eat again. So yeah, that's all I want to implement for this video. Thank you very much for watching. I'll upload the rest of the videos soon, and yeah, I hope you learned something. So yeah, until the next one, goodbye.